Hi everyone! Welcome to our learning activity video on Senior High School Statistics and Probability, Quarter 3, Week 1, C. For the objectives, the learner illustrates a probability distribution for a discrete random variable and its properties. What is a discrete probability distribution? A discrete probability distribution, or another name is probability mass function, consists of the values a random variable can assume. So what are the properties of a probability distribution? Number 1, the probability of each value of the random variable must be between or equal to 0 and 1. So the probability cannot be negative, and it could not also be more than 1. There is no such probability as 1.25 or 1.0001. As long as it is more than 1, it is not a probability of each value of the random variable. For the notation, we have here 0 is less than or equal to the p of x, or this is the probability of x. X is a random variable, and it should be less than or equal to 1. Another property is we have the sum of the probabilities of all values of the random variable must be equal to 1. So for the notation, the summation of all p of x is equal to 1. Let's do this by example number 1. Suppose 3 cell phones are tested at random. Let D represent the defective cell phones, and we have the N represent the non-defective cell phone. If we let X to be the random variable for the number of defective cell phones, then we are to construct the probability distribution of the random variable X. As defined, X is the random variable for the number of defective cell phones. So for the solution, first we determine the sample space. How many elements do we have in the sample space? Remember, we have 3 cell phones, and it could be either defective or non-defective. So we have here the sample space as stated in your learning activity sheet are this one. The elements are this one. So S, capital S, denotes the sample space. There are 8 elements in the sample space. Note that in determining the number of possible elements in the sample space, we use the formula 2 raised to n. In this case, why is it 2 raised to n? Because 2. Why 2? Well, there are 2 possible outcomes given a cell phone. It could be either D for defective or N for non-defective. So there are 2 possibilities. Why 3? Because there are 3 cell phones. So 2 raised to 3 or 8. As you can see in this elements in the sample space, this is the 8 elements in the sample space. How did we generate or we get this 8? Then it's 2 raised to 3. Let me show you this by a diagram. We have here a tree diagram. So we let D represent the number of let D represent the defective cell phone and N be the non-defective cell phone. So we have the first cell phone. It could be either D or N. Then on the second cell phone, it could be either D or N. D or N. So let me discuss this first. Given that the first cell phone is a defective one, the second cell phone could be either defective or non-defective. Another one is this possibility. Given that it's a non-defective cell phone, the first cell phone is a non-defective one, and the second cell phone could be either a D or an N. And for the third cell phone, then given a D on the first, another D on the second, then there's a possible one is it could be a D on the third cell phone. Another is Given the first and the second cell phones are defective, then the third cell phone could be non-defective, and so on. So this process continues. So given the first cell phone is a defective one, the second is non-defective, then the third is a defective. And another possibility is the third cell phone is non-defective. On the other hand, given the first cell phone is a non-defective one, the second is a defective one, then the third could be either a defective or non-defective cell phone. And also given non-defective for the first cell phone, the second cell phone is non-defective still. The possibility are defective and non-defective cell phones. So if we gather all this, we have the sample space. So on the first element, anyway, the elements are not necessarily in order. You can pick any elements, but for the sake of discussion and for the unorganized discussion, then we just have to trace this tree diagram here, D, 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 then D and D, and so on, and so on and so forth. So next is we count the number of defective cell phones in each outcome in the sample space and assign this number to this outcome. So we have to complete the following table. So we have the table for possible outcomes, then the value of the random variable x, where x is the number of defective cell phones. Let's do that. There's another way of doing this. Since there are 8 elements, you divide 8 by 2. That's 4. So you write down first the 4 Ds, or the 4 defective cell phones, and on the first chosen cell phone, and then the 4 non-defective. And then on the second cell phone, possibilities are defective, defective, non-defective, non-defective. So in this case, we have 4 divided by 2. So 2D, or 2 defective, 2 non-defective, 2 non-defective, and another 2 non-defective. And on the third cell phone, it's just an alternate defective, non-defective, defective, non-defective, and so on and so forth. Okay. Once we're done, then how many Ds? Remember, the random variable x is defined as the number of defective cell phones. In this possible outcome, number 1, then there are 3 defective cell phones. In this outcome, there are 2, another 2, then we have another 2 defective cell phones. Then this one is there is only 1 defective, another here is 1 defective, and 0 defective, because all of these are non-defective cell phones. So we're done with this random variable. We move on to the next. Now for the third one, there are 4 possible values of the random variable x, as we can see in the previous table. It says here, no defective cell phone occur once out of the 8 possible outcomes. This outcome is the triple N, or there are 3 non-defective cell phones. So it says here, no defective cell phone occur once out of 8 possible outcomes, so 0. And out of that, let me show you the previous table. Let me go back to the previous one. Here. How many zeros are there? So it's 1 out of how many possible outcomes here? There are 8. So 1 out of 8. So the probability of having x equal to 0 or no defective cell phones is 1/8. And how many has 1 defective? So how many ones? 1, 2, 3. There are 3 out of 8. So the probability of x equal to 1 defective cell phone is equal to 3/8, or 3 out of 8. What is the probability of x equals 2? So we have how many 2's? 1, 2, 3. There are also 3 2's, so we have 3 out of 8. And the last one, how many 3 defective cell phones? Or what is the probability of x equal to 3? That is 1 out of 8. So let me show you the table here. And let me discuss this one. We're here now. One defective cell phone occurs 3 times out of the 8 possible outcomes. So meaning 3 out of 8. Then 2 defective cell phones occur 3 times. Okay, 3 out of 8. And then 3 defective cell phones occur once out of the 8 possible outcomes. So we have 1 out of 8. Now you will notice that these probabilities here, let's see, recall the 2 properties earlier that we have discussed. The first one is that all the probabilities are fractions between 0 and 1, or it could be equal to 0, it could be equal to 1, and between those numbers, it could be either decimal or fraction, and that is between 0 and 1. And so with 3/8, it's between 0 and 1, 3/8 another one, and so on. So meaning property number 1 is satisfied. Now let's try to move on to number 4 before we proceed with let's check later if property number 2, which is the sum of all the probabilities, equal to 1. So we construct the probability distribution mass function of a discrete random variable x. So for the number of defective cell phones, we have 0, 1, 2, and 3. Then their corresponding probability, P of x equals P of x equals 0 is 1/8. P of x equals 1 is 3/8. P of x equals 2 is another 3/8. And then the probability of x equals 3 is equal to 1/8. So note that the sum, if we sum this up, 1, 3 plus 3 plus 3 plus 1, it's 8/8, or simply equal to 1. So property number 2 of the probability distribution table was satisfied. So in this case, to determine that the above probability distribution function satisfies the true property, we have to verify, and we already had verified that. And these are the properties that this particular example number 1 satisfies. So then we can say that this is a probability distribution function of the experiment in example 1. Okay. So we move on to the exercise similar to example 1. Suppose 3 unbiased coins are tossed. What do we mean by unbiased? So the coin is a fair coin. Okay? So meaning there is no possibility for either a head or a tail will come out to a disadvantage of either a head or a tail. So unbiased coin, meaning there is no element of bias. Okay, let H represent the heads and T represent the tail. If we let X be the random variable for the number of heads that will occur, we have to construct the probability distribution of the random variable X. Then we have to compare the answer in the example given earlier, and we have to answer the following questions below. So first, we have to determine the sample space. Again, the sample space is similar to the one that we had discussed in example 1, only that instead of writing here the defective, then we write head, H, letter H, instead of letter D. And instead of writing letter N, then we have to write letter T for the tail. Okay. So we have 2 raised to 8, the same. Why 2 raised to 3? Because there are 2 possibilities. Why 2? Head or tail. Then why 3? Because there are 3 coins to be tossed. So 2 raised to 3 equals 8. So 8 possible elements in the sample space. Okay. So for the tree diagram, it's similar to the one I had discussed earlier, only that I changed here the first CP earlier. Then we have first coin toss, second, and third. Then we have the D earlier, I changed it to letter H, and then we have the N for non-defective, I changed it to letter T, that stands for the tail. So let me just browse this so that we can move on to the next. Okay, so these are the 8 possible outcomes in this kind of experiment using a tree diagram. Okay, and then we will come up with the number of heads and the number of tails. And then we have to complete the table. So here is already the number of heads that occur. That's the random variable x, and x is defined to be the number of heads. So what are the possible outcomes? It's still the same procedure that we had, only that instead of writing letter D, we have H, and instead of writing letter H, we have T for the number of tails. So similar example, they are actually the same except that H, we change D to H and the N to T. So for this, then, we have to recover, of course, the probability that x equals 0 is 1/8. The probability that x equals 1 is 3/8. The probability that x equals 2 is 3/8. And the probability that x equals 3, x stands for the number of heads, we have 1/8. And of course, we have to construct the probability distribution function of a discrete random variable x. Then it's similar to the example 1 that we had discussed earlier. And the sum of the probabilities is equal to 1. And take note that the probabilities here are between 0 and 1. So this is a probability distribution mass function of the discrete random variable x, where x is the number of heads that occur in an experiment of tossing 3 unbiased coins. Okay, the two properties are satisfied. Okay, we move on to the question. Observe the probability distribution on both the example and this exercise. What do you notice about the probability of each value of the random variable? Well, answer. This is my answer. You could have your own answer or you could rephrase your own answer. Well, both probabilities in example 1 and exercise 1 are the same. Yes. And the summation of all the probabilities is equal to 1. Get the sum of the probabilities of all the values of the random variable in the example and in the exercise. We have done that. What sum did you get? Of course, the sum is 1. And write your conclusion regarding this matter. So, possible conclusions. Example 1 and exercise 1 has similar solutions since the number of possible outcomes is 2. In example 1, we have either defective or non-defective cell phones, and in exercise 1, we have a head or a tail that comes out with a coin tossing. Both have the same number of elements in the sample space, 2 raised to 3, that's 8. And both have similar tree diagram. What else? Both have the same probability distribution mass function. So I wasn't able to write it here, but that's also one of the conclusion. Example 1 and exercise 1 has the same, I mentioned it earlier, so this is it here. Well, for the reference, I have it here. And this is all for now. See you in the succeeding learning activity video that I'm gonna make just for you to understand statistics and probability.
If you are not yet a subscriber of my channel, kindly subscribe and please don't forget to like and share. And if you are a subscriber, you will be updated with more uploads for these learning activity videos. Thank you and always stay happy, healthy, and safe. Bye!